So we have seen Whitworth mechanism and we have seen slotted bar mechanism. So if you look at both the mechanisms, this is the slided rank chain, okay? This is slided rank chain. This is slided rank chain. So this is link number 1, this is link number 2, this is link number 3, and this is link number 4. These are different 4 links. If you look at the Whitworth mechanism is the application of second inversion, okay? So you will get Whitworth mechanism by fixing link number 2. So by fixing link number 2, we will get Whitworth mechanism. So in Whitworth mechanism, if you see this fixal link is link number 2 and the crank is link number 3. I can say like this, in Whitworth mechanism, if you see this is connecting rod, right? So length of connecting rod is more than length of crank. So in Whitworth mechanism, so length of crank, I mean this connecting rod, this is more than length of fixal link. In Whitworth mechanism, I can say you have fixed this link. When you fix this link, link 3 can be rotated about this point and link 1 can be rotated about this point. So link 3 is acting as a crank. So I can say crank of Whitworth mechanism is longer than its fixal link. Whereas if you see the slotted bar mechanism is an application of third inversion. So we get slotted bar mechanism by fixing link number 3. By fixing link number 3, we get slotted bar mechanism. In slotted bar mechanism, you can see fixal link is longer than the crank. Longer than its crank, I can say. So if you see, compare both Whitworth and slotted bar mechanism. So in Whitworth mechanism, fixal link is shorter, whereas in slotted bar mechanism, fixal link is longer than its crank. So this is the kinematic difference between these two. And there are other differences. Just write down like this. Comparison between Whitworth mechanism and slotted bar mechanism. Comparison between Whitworth mechanism and slotted bar mechanism. So comparison between Whitworth mechanism and slotted bar mechanism. So this is Whitworth, and slotted bar mechanism is obtained by fixing the connecting rod. So that is link number 3, okay? This is link 1, link 2, link 3. Slotted bar is obtained by fixing this link. This is slotted bar. Slotted bar mechanism. Just write down like this. In Whitworth mechanism, crank is longer than its fixal link. Crank is longer than its fixal link. In Whitworth mechanism, crank is longer than its fixed link. Next, in slotted bar mechanism, crank is shorter than its fixed link. Crank is shorter than its fixed link. Crank is shorter than its fixed link. So in exam, in questions, they don't mention whether it is Whitworth mechanism or slotted bar mechanism, okay? So just by looking at length of crank and length of fixed link, so you have to determine whether, you have to say whether it is a Whitworth mechanism or slotted bar mechanism. You have to identify the mechanism by just looking at this link lengths, okay? So if I give some arrangement like this, fixed link is shorter and crank is longer, it is a Whitworth mechanism. If fixed link is longer and crank is shorter, it's a slotted bar mechanism. So for Whitworth mechanism, you know how to draw the two extreme positions. For slotted bar mechanisms, you know how to draw the two extreme positions. So by drawing two extreme positions, so we have to do velocity analysis, okay? Whenever you get any question from a quick return mechanism, you always draw the two extreme positions, okay? Why you have to draw the two extreme positions? Because for calculating quick return ratio, you need to know what is the angle turned by the crank for forward stroke and return stroke. And that can be known only by drawing the two extreme positions. So initially, where was the crank when the tool is at the left extreme position? When the tool goes to the right extreme position, what is the position of crank? What is the angle turned by the crank? You want to calculate that. So you have to draw the two extreme positions, and then proceed. Okay, and how to identify the mechanism? So based on this length of cranks and length of fixed links, we have to identify the mechanism. Okay. Next, see here, there's one more thing between this Whitworth and slotted bar mechanism. So if you look at this Whitworth mechanism, so this is Whitworth mechanism. So I call this is O, this is A. So this is link number 1. This is link number 1. And this is Whitworth mechanism. Construction of Whitworth mechanism was something like this. This is the tool. This is the tool. So this is B. This is fixed link and this is rotating. So if you look at this Whitworth mechanism, so in Whitworth mechanism we have seen this. So this is stroke length, right? So this is OC. Stroke length is 2 times OC. Stroke length is 2 times OC. In Whitworth mechanism, stroke length is 2 times OC. If you want to increase the stroke length, what you do is you just increase this extension. If you want to decrease the stroke length, you just decrease this extension. So stroke length can be changed by just changing this extension. And if you look at the 2 extreme positions in Whitworth mechanism, the 2 extreme positions of Whitworth mechanism are like this. This is one extreme position for the Whitworth mechanism, and this is another extreme position for Whitworth mechanism. These are the 2 extreme positions for Whitworth mechanism. So, and we have seen, so if I say this angle is alpha, this angle is also alpha. If this is alpha, this is 90 minus alpha, this is 90, and this angle is alpha. This angle is alpha. So if you see quick return ratio, so quick return ratio I am writing it like this, greater than 1. So it is time for forward stroke to time for return stroke. So I can say like this, it's 180 plus 2 alpha divided by 180 minus 2 alpha. Quick return ratio is 180 plus 2 alpha divided by 180 minus 2 alpha. This is quick return ratio. And if you look at this alpha value, so alpha value in this case I can say sin alpha is, this is the opposite side, this is radius of crank. Sin alpha is opposite side divided by this one, hypothesis. So I can say this alpha value depends upon length of fixed link and length of crank. Alpha value depends upon length of fixed link and length of crank. So if you change this, if you change length of fixed link or if you change alpha, so or I mean if you change length of fixed link or if you change R, only then alpha gets affected. If alpha gets affected, then only I can say quick return ratio gets affected. So but here in this case, you can increase stroke length by increasing this extension. You can decrease stroke length by decreasing this extension. So when you are changing the stroke length, these 2 lengths are not getting affected. Okay, these 2 lengths are not getting affected, or I can say alpha is not getting affected, or quick return ratio is not getting affected. In Whitworth mechanism, quick return ratio is independent of stroke length. Okay, quick return ratio is independent of stroke length. So quick return ratio can be, stroke length can be increased or decreased without affecting quick return ratio. Or quick return ratio can be changed without affecting stroke length anyways. They are not dependent, they are independent. So for the same stroke length, I can have different quick return ratios, or for the same quick return ratio, I can have different stroke lengths. Either I increase the stroke length or decrease the stroke length, quick return ratio will not change as long as I don't change these 2 lengths. Okay, so for smaller stroke lengths, I can have the same quick return ratio. For larger stroke lengths, I can have the same quick return ratio in Whitworth mechanism. If you look at slotted bar mechanism, this is length of fixed link. These are the 2 extreme positions. I'm running right. These are the 2 extreme positions. So this is stroke length. Okay. This is stroke length. In slotted bar mechanism, we have seen that. So if I say this is alpha, this angle is alpha. So this angle is 90 degrees. This is 90 minus alpha, and this angle is alpha. Okay. This angle is alpha in slotted bar mechanism. In slotted bar mechanism, if you want to increase stroke length, so for this alpha, I can say this is the stroke length. If you want to increase stroke length, so I have to go like this. You have to increase stroke length. If you are increasing stroke length, I can say alpha increases. Okay. If you want to increase stroke length, alpha increases. So I can say for larger stroke lengths, so I can say alpha is large. Okay. So for larger stroke lengths, so alpha is more. If you want to decrease stroke length, you need to decrease alpha. So I can say like this, in slotted bar mechanism, if you want to increase stroke length, so we need to increase the value of alpha. If you want to decrease stroke length, we need to decrease alpha. So whenever you are changing the stroke length, alpha is getting affected. If alpha is getting affected, I can say quick return ratio gets affected. So for larger stroke lengths, alpha is more, I can say quick return ratio will be more. For smaller stroke lengths, alpha will be less, quick return ratio is less. So in slotted bar mechanism, So if you increase stroke length, alpha increases and QRR increases. If you decrease stroke length, alpha decreases and QRR decreases. So I can say slotted bar mechanism is not suitable for smaller stroke lengths. Whereas Whitworth mechanism, so either you increase or decrease stroke lengths, so alpha will not get affected, QRR will not get affected. Just write down like this. So comparison between Whitworth mechanism and slotted bar mechanism. So the first comparison is, so in a Whitworth mechanism, if you see, so this is link 2 is fixed in Whitworth mechanism. So crank is longer than fixed link in Whitworth mechanism. So in slotted bar mechanism, if you see, so the fixed link is longer and crank is shorter. Okay. So depending upon if the fixed link is longer than its crank, it is slotted bar mechanism. If crank is longer than fixed link or fixed link is shorter than crank, that's Whitworth mechanism. So that's one difference. Okay. Let's start comparison between Whitworth mechanism and slotted bar mechanism. So I do the first one. So crank of Whitworth mechanism is longer than its fixed link. Crank of Whitworth mechanism is longer than its fixed link. Next item. Crank of slotted bar mechanism. Crank of slotted bar mechanism is shorter than its fixed link. Crank of slotted lever mechanism. Crank of slotted bar mechanism is shorter than its fixed link. Crank of slotted bar mechanism is shorter than its fixed link. Next, write down like this. Next, write down like this. In slotted bar mechanism, if stroke length increases, alpha increases implies, I can say quick return ratio increases. If stroke length increases, alpha will increase and quick return ratio will increase. Next item. If stroke length decreases, alpha decreases and quick return ratio decreases. Alpha decreases and quick return ratio decreases. Alpha decreases and quick return ratio decreases. Alpha rate decreases and quick return ratio decreases. Next, I do like this. In slotted bar mechanism, since quick return ratio is smaller for smaller stroke lengths, it is not suitable for smaller stroke lengths. Slotted bar mechanism is not suitable for smaller stroke lengths. Slotted bar mechanism is not suitable for smaller stroke lengths. Slotted bar mechanism is not suitable for smaller stroke lengths. Next, write down like this. Next point. In Whitworth mechanism, stroke length is independent of alpha. 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 Stroke length can be increased. Stroke length can be increased and decreased without affecting quick return ratio. Stroke length can be increased and decreased without affecting quick return ratio. Stroke length can be increased and decreased without affecting quick return ratio. Therefore, Whitworth mechanism is suitable for both smaller and larger stroke lengths. Whitworth mechanism is suitable for both smaller and larger stroke lengths. So Whitworth mechanism is suitable for both smaller and larger stroke lengths, whereas slotted bar mechanism is suitable only for larger stroke lengths. For smaller stroke lengths, alpha will be small. Okay. This is the basic difference between slotted lever mechanism and Whitworth mechanism. So we have seen three inversions. Okay. First inversion of slider crankchain. The applications are IC engine and reciprocating compressor. The second inversion of slider crankchain, the applications are Whitworth mechanism and radial engine or rotary engine. Sorry. So the third inversion of slided crank chain, the applications are slotted bar mechanism and rotary oscillating cylinder engine. Oscillating cylinder engine and slotted bar mechanism. And we have seen a rotary engine. Rotary engine is also called as a gnome engine, and oscillating cylinder engine is also called as a marine engine. This point keep in mind. So sometimes in some PSUs they ask these questions. Okay. So this is all about three inversions. Okay. So first point is it's about Whitworth mechanism, right? So crank of Whitworth mechanism is longer than its fixed link. The crank of Whitworth mechanism is longer than its fixed link, and second I told crank of slotted bar mechanism is longer than the fixed link. So it's a comparison between crank and fixed link lengths. Next item, fourth inversion. Fourth inversion of slided crank chain. This is slided crank chain. This is link number 1, link number 2, link number 3, link number 4. This is O, this is A, and this hinge is B. This hinge is B. Okay. Fourth inversion. Fourth inversion. So to get fourth inversion, I'm fixing link number 4. So I'm fixing link number 4. Okay. I'm just rotating this everything by 90 degrees. So when I rotate everything by 90 degrees, this is link number 4. Okay. This is link number 4. So inside this link number 4, I have link number 1. This is link number 1. This is link number 4. This is link number 1. Link number 4, link number 1. At the end of link number 1, it is connected to link number 2. It is connected to link number 2. And link number 2 is connected to link number 3. So link number 2 is connected to 3, 3 is connected to 4. 3 is connected to 4. This point we call it as B. This is A and this is O. This is a mechanism. Okay. This is a mechanism. I fixed link number 4. I fixed link number 4. Link number 4 is fixed. This is a mechanism. This is a mechanism, okay? So in this mechanism, what I'm doing is, to make the mechanism useful, I'm extending this link number 2. I'm extending this link number 2. So by extending this link number 2, I can operate this link number 2 about this hinge. So I can rotate this link number 2 about this hinge. When I rotate link number 2 about this hinge, you can see this link number 2 will be rotating about this hinge. And as link number 2 will be reciprocating about that hinge, this point O will be moving up and down. Okay? Point O will be moving up and down. So as point O moves up and down, I can say this link 1 will be moving up and down. So this is a slider, okay? This is slider. Inside this it's reciprocating, okay? So I'm just changing the shape of this. I'm removing flush inside this link number 4. And at the end of link number 1, so I'm welding a piston, okay? I'm welding a piston. This is called as plunger, okay? I'm welding a plunger. And I'm changing the shape of link number 4. Okay. So the application is a hand pump, okay? The application is hand pump. So when I reciprocate this link number 2, so this point 3 will be, link 3 will be, this will be moving in a curved path, and this will be reciprocating. And as the plunger reciprocates inside link 4, so it will create some low pressure and we will be having water output. So really, link 2 is crank in your IC engine, okay? So in your first inversion, we call that as crank and all. Whenever I say crank, any rotating part is called as crank, okay? Any rotating element is called as crank. Link 1 oscillates. Link 1 will be moving up and down, okay? It's something like this. As I move this upwards, I can say this will be oscillating like this, and this will be going inside. And so one will be moving up and down. Point O will be moving up and down. Okay, it's a guide. It will be moving in the guide. Okay, this for link 1, this tube is the guide. It just moves along the tube. This is a hand pump. Okay, the application is hand pump. Link 1 reciprocates, yes. Anshu Pandey. Whenever I say statically indeterminate structure, that is a superstructure, okay? Superstructure we call it a statically indeterminate structure. Okay. If degrees of freedom comes out to be negative, we call it as statically indeterminate structure. Okay. Write an application. Applications for the fourth inversion. Application for fourth inversion. Hand pump. Hand pump. This hand pump is also called as bull engine, okay? Bull engine. Hand pump is also called as bull engine because it demands more amount of energy. It's called as bull engine, okay? These are the different inversions, okay? So the applications are very important. In IAS, many times they ask the questions based on these applications, okay? Let's go through this question. So quick return mechanism. This is your slotted bar mechanism, okay? You can see the slotted bar mechanism. The cutting angle is more than 180 degrees and the return angle is less than 180 degrees. Cutting angle is more than 180 degrees and the return angle is less than 180 degrees. And you can see the return is very fast. I don't know whether you have to. You can see the return is very fast, okay? It's quick return, okay? And in this kind of arrangement, in a slotted bar mechanism, you will get maximum velocity when the tool is at the midpoint of the stroke, okay? When the tool is at the midpoint of the stroke, you will get maximum velocity for the tool. You give two positions, you can see the crank positions are given. So when the crank rotates by 90 plus alpha, then you will be having maximum velocity. So if you look at this, crank of Whitworth mechanism is, what's the answer for this? For Whitworth mechanism, crank is longer or fixed link is longer? Kumar, alpha depends upon length of links, okay? Length of links. So crank of Whitworth mechanism is longer, okay? It's longer than its fixed link. Its fixed link. And the second one is crank of slotted bar mechanism is shorter than its fixed link.